This lesson, we'll look at how to enhance our chat GUI so that we can connect it to I/O channels and send a message when the user types in some text and display text that is received from elsewhere. To continue with the principle of taking one step at a time, we're not actually going to do the networking yet. Instead, we'll use the console as the other end of the system. So for our next step, we need to be able to type input into the single line text field, and when we press enter, we want to send that somewhere. Conveniently, it turns out that pressing enter in a single line text field causes an action event just like a button. So let's start by adding something to the text field that responds to us pressing enter. We'll add an action listener using an anonymous inner class. We'll split that line, and then inside there we will add a new action listener, and we'll split that line. And notice that NetBeans is complaining. First we need to import action listener, and then we need to implement the abstract methods. Now we'll reformat with Control-Shift-F. That makes it a little bit more readable. So now we have entry text add action listener. We immediately add the action listener as an anonymous inner class, and the implementation will go in here. Now at the moment this is throwing an exception, which isn't terribly helpful. We'll delete that, and then let's think about the behavior we want. What we actually want to do is to grab the contents of the text field, write it to the output, and then it would be nice to blank out the text field so that we're ready for the user to provide the next entry. We can do that by calling the method getText on the entry text object and then sending that initially to the system output. Then we can set the text on the entry text and set it to null. Let's save that. We'll go back to our test program and see what it does. So if we type in here, we see that it does in fact generate the output here. That looks like a good start. Now we don't really want to send the output to the console in the long run. We want to send it over a network. Conveniently, we're going to find that outputting to a network connection is essentially the same as outputting to any other output stream. So if we modify the constructor to take a writer as a parameter, let's use that instead of the console as our destination. Then for now, we can still test it using the console anyway. So let's go to our chat client again, and we will add a second parameter. We need an import for writer. A second parameter called output of type writer, and guess what? We've labeled it final as well. You've probably guessed correctly, we're going to be using that inside our inner class, and therefore it needs to be labeled in that way. Let's change the behavior of our action event handler. Instead of sending the line that we've just read to the console using systemoutprintln, which is specific to the console, now we're going to change that to say output.write. We're going to take the line and we're going to append to it a new line character. We will also add a second line that says output.flush. The reason we're doing that is that not all I/O gets written immediately at the time when we make the statement to send it. With console I/O, output will be sent immediately because the system knows that that's why we're sending it. We want someone to read it. But this output.flush statement will force the system to send our message to the output. Without it, it's actually likely to sit in a buffer going nowhere, and we'll be wondering why our program doesn't work. Let's also add something that outputs this message to our chat window. Here let's say chat text append, and then we'll prefix the message with me : so that we know that this is our message. We'll embed the line in there and put a new line on the end of it. So now when we send something, it should show up in our output window. Well, of course, rather inconveniently, we can see some errors have shown up here. It turns out that output.write and output.flush, those methods output and flush, are declared as potentially throwing I/O exceptions, and we have to handle those. We first need to think about what this might mean. It seems most likely that if a network connection were broken, then an attempt to write to it would have to fail. So we'll work on that basis, and we'll put a message in the console indicating that the other party hung up on us. That's not perhaps as full or robust a response as it might be to this situation, but it seems like a pretty good start. So we'll add, just above here, a try block, and then after here, we'll add our catch block. We need an import for IO exception, and we will reformat that. So now, if these lines fail, either of them, we'll end up catching an exception here, and then what we'll do, we'll put a message that says the other party hung up in our chat log window. So let's test that. Come across here, we'll save this. Now before we can test that, we need to modify our test code, because now of course we need to provide a second argument to the constructor that is the writer that we want our GUI to write to. We need a writer, not an output stream, and that writer is going to be connected to the system.out channel. So we can simply add in here a new output stream writer, for which we need an import, and connected to system.out. So we'll save that, and then let's run it. So there's our window. Let's bring it down here a little bit. When we type in here, we still get the output showing up here. But the important thing is we have now generalized the chat GUI so that instead of always writing to system out, it writes to the writer that we give it. The next thing we need to be able to do is to collect input from somewhere else and send it to the chat window. We can cheat again and test this using the console, at least initially. But first, let's consider that we will not be getting messages from the network via the GUI. So there are not going to be GUI events to handle this. We'll be looking for these network messages in the main thread, and we can't write directly to the GUI from that thread. So we're going to need to add a method to our chat UI class that will allow us to safely update the chat window with a new message. Let's put that just after this method, like that. So here we've declared a method, append text. We've said that it's going to take a message as its argument. Oh look, this one's labeled final as well. You can probably guess why. Sure enough, inside here, we use the swing utilities invoke later, which means now we're going to create this anonymous inner class for our runnable, and the run method simply says chatText.append, and then we say they, indicating that it's the other party that sent this message, put the message in, and put a new line on it so that our messages don't all run together. So this should be getting fairly familiar now. Now we can call this from our test method when we've read something from the console. Let's go across there. So the first thing we're going to need to do is to actually get a hold of the system input, and we'll need some imports for these things. So we connect an input stream reader to it and a buffered reader to that. Remember that the buffered reader is the one that gives us the convenient read line method. We're also going to need to keep a handle on this chat UI object so that we can call the append text method on it. So now we have a variable that will refer to that for later use. Next thing we need is a loop that reads from the keyboard and calls append text every time it has a new line to update. Let's put that here. Of course, this might throw exceptions. Since this is the test, we'll just cheat with this and declare that the main method might break. So in here we'll say throws throwable. We'll save that, and then we'll run that and see how we're doing. Now, of course, we're going to need to resize these windows to see what's happening. We'll bring this down about there-ish, move it over there. Now we can get both of these side by side, and we should find that when we type in here, that shows up in here, and when we type in here, it shows up in there. So now our GUI window is capable of sending messages from here to a specified writer and receiving messages and updating its display from the main thread. So there we have it. In this lesson, we've modified our GUI so that it connects to a writer and sends updates to that writer based on the user's input, and simultaneously can be updated from another thread as the result of input messages. Our next step will be to connect this to the network instead of to the keyboard.